Hello everybody, and welcome to Tim Time again. The SB200 has come out to join us. There's a couple things I wanted to look at before I make a decision whether I want to get some tubes. It seems the what are they? The 572Bs are all but gone, other than Pentalabs is one that comes recommended. A couple different ones. So anyhow, a couple things I wanted to look at. I wanted to check this capacitor here. I hear that's a common failure point. And take a look at the grid resistors and the grounds back here and see how that all looks. I checked a lot of things out on this before and it was working pretty good. One thing I never really messed with was the TR relay, or the transmit relay underneath, so I want to take a look at that as well. But without further ado, let me prop this up on something so it doesn't scratch anything, and we'll take a look at some stuff. Alright, back here with the SB200 Heathkit. So up in here are the capacitors for the filter section, for the inlet, the input matching network, so to speak. And I got rid of the old domino style capacitors. Everybody says get rid of those and put the new mica capacitors in. Those are micas, supposedly micas also. While I was doing that, I happened to notice that there was a few that weren't the value that should have been in there, so somebody was playing around. And I know that I don't know, maybe somebody tried to make this for 10 meters for CB, but there were some changes done to the 10 meter side too, even inside I'm trying to see where I'm pointing. Inside here, there were some changes done, but I'm putting everything back to normal. At least I hope I am. So those are all changed. And from what I'm reading, when the tubes are in here and this thing's fired up, this impedance looks to be somewhere in the neighborhood of, it was pretty wide, like 300 to 500 ohms is what it actually looks like coming into the matching network. So the idea behind this matching network here is to match the 52 ohms from your radio to be the impedance for the vacuum tubes. I haven't quite looked that up yet to verify that that's correct, but what I did was I got a 300 ohm resistor here, and I just put it from basically where the input of the tube would be to ground. So that would appear to be somewhere right in the middle of that 200 to 500. Maybe it should be a little higher, I don't know. So what I want to do now is, if you'll notice here, and we can zoom in on this a little bit, a new toy, a Nano VNA vector network analyzer. It's almost like a glorified antenna analyzer. It does a lot more than an antenna analyzer, and it's way cheaper. So anyhow, what I'm going to do is I'm going to set this up to look at all my nifty stuff here. I'm going to set this up to actually be able to look into this as if it was the radio, and we'll see what kind of impedance or what type of SWR we get coming into it. Unless it's really radical, I'm not going to make any changes because, like I said before, I'm not really sure what the actual value of the impedance or resistance that the radio should be seeing is. Just from what I'm reading online, I'm seeing everybody's saying around that area. So the resistance that I could use in there would be the wide gambit of everything. So let me get this set up. What I made was I made some things here to actually calibrate this. They give you the little slugs here for open, short, and load. But I'm actually made them with some old PL259s I had laying around. So I don't know. I don't know if it's going to make that much of a difference. But the way it seems is you would want to be calibrating everything to, bring this over, to your last input, which would be going into the radio here, not way down here. So it would be checking the wires and everything, which I have another story about that. When I was just trying this thing out, I found that my dummy load wasn't working correctly just when I was using this. So already that found a problem for me. So anyhow, we're going to go and let's see. The first range I'm going to look at, we'll say, is 28 to 29. So we'll set that up. Let's see. First off, I'm going to look at what I want to look at. The only thing maybe I'll leave the Smith chart on there and the SWR. So bear with me. I'm new at this as well. Display, trace. We don't need that one. We don't need that one. So let's see. Trace 0. Select that, and we'll go back. Wait. Why are they still there? Hang on. So we didn't want you. You go away. You go away. Okay. Trace 0 is going to be channel S1. And we'll make trace 0 SWR. How's that? Go back. And then trace S1. Go back. We're going to make a channel 1. And format, we're going to make that the Smith chart. That really looks weird, huh? Back. Let's see, one's SW and one's Smith. Okay, and they're both channel 1. All right, so we're good there. So now we have to go and do the calibration. So the first thing we'll do is, where is it? Go. Oh, we want to set the stimulus. That's going to be the frequency. So we're going to set it for the start is going to be 28 megahertz. So 228 M. We'll set the stop for 29.6 megahertz. And now we want to do the calibration. Calibrate. So the first thing we'll do is the open. And I took that. So the next thing we're going to do is the short. And that's, well, I didn't mean to do the short yet. That is when I put the shorted terminal in, and that's this one here. So I put the shorted terminal in. And now I hit short again, and you'll see the little thing go across the bar, and it calibrates itself to what a short should look like. Okay. And then the next one I'll do is this one here. I don't know if you can see in there, there's a 50 ohm resistor in there. So that'll be the load. We'll put that on. And we'll hit load. And there you go. So all three are done. And if you look in the Smith chart, the guy's right in the middle. So that's right where it should be. So now we're going to go to the back. We don't have to do any of the other stuff because that's the only things we're going to need. So now I'm going to take all this crap off and plug this right into here. Now again, you probably couldn't see what I was doing when I had the other stuff, but I don't think it was that important. I'm just putting coaxial connectors on. So let's see. This is so you can see it and I can see it. Let's turn it this way. Oh, let me put this guy on 28 on band. I believe that's 10 meters. And then when I short this up, oh, there we go. So we can see the band way over here. Let me give me a second to lock those terminals down. I'll just use like a Q-tip or something. Need something that fits in there. All right, hopefully that'll stay there. So all the way up at the 29/6 end of the band, the SWR is 2.3637. I don't know if you can really see that. 2.236. So as I move the cursor down, we're going to get down to that end of the band, and that's more or less where I'm going to be using this. Is probably right in the area of 28.5. So let's see. 28.512, the SWR is still under 1.2. I mean, under 0.2, it's 1.905. Now, when I get way down at the very beginning of the band, it's down to 1.4. That's what my SWR is, and that's down at 28.128 is the frequency. Like I said, I could probably fine-tune it a little bit by either changing the capacitor to get it more where I need it to be, or maybe even eke out a little bit more by actually adjusting the core here. I don't know if that's ever been adjusted. I don't know if I'm going to adjust it because it's still acceptable, even though it is kind of high. I think my personal idea is I'm going to keep it below 2, as long as it's below an SWR of 2 to 1. The manual for this says 3 to 1, but I don't know if I'd go that high. Anyhow, I just don't even know if that's an accurate location to be with a 300 ohm resistor. If I put a different resistor in, that would definitely change this location. And just to prove my point, let me just throw something else in there. All right, here's another 300 ohm resistor. So if I put this in parallel, that would give me about 150 ohms. And that won't reach, so let me use a little jumper wire. Wow. So just me moving things around, it might be the, yeah, it's the, not doing a good job of holding the relay down here. All right. So there we are again at 21.6, 1.4, blah, blah, blah. Okay, so let me put this guy on here. And I know this is kind of unprecedented, but I'm just doing this to prove a point. But see, in lowering my resistance, look at that. It's changed this point to the peak area being, come on, almost 28.2 at 1.2. And then the area I said I'd be at before was what, 1.9. So 28.5 is 1.4. So as you see, I don't want to start tuning and aligning things because I don't know exactly what the impedance is. As long as it's in the ballpark, as long as it's not way off scale, I'm good with it for now. I mean, the amplifier worked before. I never really used it that much, but the person I bought it off tells me it worked. So let's see. So that's that band. So what do we have? The next band, let me look and see. I believe is going to be 15 meters. Let me just get my little cheat sheet here because I always seem to forget the bands. All right, so for 15 meters, we want, let's see, 2100 to 21450. That's what it's going to sweep. So we're going to have to change this again. So we pull this off. And we're going to change the band, and then we have to recalibrate it because we changed. So I don't know what that is. Let's go back. Back. Stimulus. Start. Go 21M. Go stop. .45. So somewhere in that area. All right, so now we're going to have to calibrate it. It's kind of hard looking at it sideways, like trying to see where the numbers are. So let's see. Go back. Go to calibrate. Go to calibrate. We'll do the open first. I don't know if it matters if you do them out of order or not. I don't see why it would. And the short. Let me just see what you're looking at here. All right, you're still looking around the same general area. So next is the short. And that's done. Then comes the 50 ohm load. And do the load. Load's done. So I'm going to turn this from 10 meters to 15 meters. We'll pull this off. We can tell this to go back. And we're going to plug it into the radio here, in theory. All right, so this, let's do this. This seems to be a straight line all the way across. And it is all the way across. I'm showing a 1.4 to 1 ratio. Again, I wouldn't complain about that. Let's see. Let's just see what happens if we put this on this band. If it has the same or any effect. And I know we wouldn't be normally using a lead this long because, oh my, look, that's telling me 1.2. Again, just by decreasing that resistance from 300. So, all right, so that's that band. All right, so here we have it. I'm using my finger to hold the relays down. You can see when I release it. So it looks like, and make sure we're on the right band. Yep, there's 40 meters. It looks like this one's pretty much straight across the band also at about 1.273. Looks like it's a little bit higher as I get down lower. But that's still very good. Well, let me turn this light, maybe you can see better without all the glare. All right. So let's go down to the last band, which would be 80. I'm not going to tell you what the problem was all along, because that was just for that band, but I was turning the wrong way. I'm thinking backwards as I'm turning the knob. So 80's what, 3, 6 to 4? Something like that. Let's see. Let's tell this thing. We want to look at back, stimulus. What? Back. Stimulus. So here we go. Start. No. Start. 3.6. And stop is going to be 4. Now we're going to have to do the calibrate thing. Go back. Calibrate. Calibrate. Okay, the open, we'll do that. That's already done. First guy on here is the resistor, so we can make that one the load. See, I'm going out of order again. Remember the bad luck that brought us last time. Oh, come on, there we go. And this will be the short. Short. And that's done. I'll pull this off. Make sure the amplifier is turned to the right direction. All right. And now I'm going to push down on, get that out of the way. Get that. I'm going to push down on the antenna relay, and there we go. So at 4, it's 1 to 1.5. And then as we get to the other end of the band, a little too hard for me to hold my fingers and do that. So at this end of the band, it's 1 to 1.6. So again, that's really not that outrageous. Nothing that I'm going to make any changes for. So what was the one we were missing? All right, so let's see. This thing keeps getting in our way here. Let's see when I hit that, what happens. There we go, it drops down. So at 14, it's 1.26, and if we come over here to the other end of the band, which is what, 450, 420, it's 1.43. So again, totally acceptable. The error was user error. That's why either I programmed the wrong frequencies or this relay wasn't holding short or holding shut. All right, so in short, I think the video, the idea was just to show the use of a nano VNA. I actually have a different video that I'm working on showing it. I didn't want to get through everything because enough people show how to use these. It's I didn't do a box opening or anything, but if I hold this up and maybe take some of the glare out of it. And of course it's going to be kind of upside down, I think, isn't it? Oh no, not for you. I can turn it that way. Ah! Oh, stop. You know, yeah, that still produces so much glare from the lighting. All right, that's the only way I can put it that it won't get a ton of glare. So you can see, I'll show you again when I close the relay, how it brings the yellow lines, the SWR. Down here is at 7 or 14 megahertz, and it goes clear up to 15. So right here is probably the top of the band somewhere. And up here it tells me that's still about 1.4 to 1, which is totally acceptable. And it might even be better or possibly worse, just because I don't know what the true impedance it's seeing. Let's see what happens when I stick our trusty jumper back over here on this wire again. This is going to be installing that resistor in parallel again. Ah. All right, lowering that resistance makes life so much better. Not so much better, but anyhow, you can see what I'm saying. Trying to get my arm out of the way there. So that's the Nano VNA. So to give you an idea, what did we say that was? About 1.4 in the middle of the band. So let's use an antenna analyzer and take a look at the same thing. Put this here like so, and I'm going to have to adjust the camera to be looking at it. Let me plug it in to power and turn it on. Leave that so it's not blocking everything. And what did we say? We were around 14 megahertz. Let's see, that's 11. We were going to say about 14.2, huh? There's 14.2. I don't know. Sure, it looks like you can see that. Now when I close the relay, what happens? My SWR goes down to about 1.5 on this one. So the other one was 1.4 something. So as you can see, this kind of, you could have done the same testing with this. As I went down in the band, closer to 14, it was better. I can't see which way I'm turning it. Oh, definitely. Yeah, it got better, 1.4. And then as I came up in the band, there at the end of the band, even higher than the end, 1 point or 2.1. So again, that's how you would have done it with this. But I thought it'd be more interesting to try it with the new VNA. Oh. All right, so to sum up then, everything here is back to original. I'll take this resistor back off. I replaced all the capacitors in question here. Put 2 new capacitors for the grid bypass and the resistors. I ordered them new, but they really look ugly. But okay, that's enough for that. Where are we? I don't know if you can see them even. This way a little bit. All right, so here's the capacitors and the resistors I was just speaking of. Cleaned up some of the solder joints in there and tried to make it more presentable. They have all these capacitors just kind of shoved together. Here's that resistor I threw in here just for testing purposes. That'll be coming back out. Replaced all the, I think I already covered that, all these. Oh, at the bottom here, what did we do? We looked at this originally a long time ago on the bottom. I stole a pointer from the amp repair guy who does a lot of nice videos on these, and put a strain relief there to hold that high tension line up there. What else did I do? Down here I didn't really do much of it. I cleaned the transmit receive relay, and that was kind of in process of testing what we were doing. I checked one of the other high voltage blocking caps up top. That looked pretty good. So what I want to do is throw the tubes back in this, put it on a dummy load and try it. Because I realized when I had the really low output, I had an antenna problem. I did not have a dummy load out there. I had an antenna out there that had come apart the gap. I think I showed that in a video or something. But anyhow, that's what I'm going to do next. This is pretty much all ready to go. I may end up replacing these RF cables. Not that they're bad or anything, but they're just old. So, I mean, they'd probably be happy to get replaced. I think that's about it. All right, the high voltage is showing about 2200. It's always been that. least on that meter. I've never tried it with the old power supply. Let's get the hardbox supply in it. We'll tune it up on 80 meters. 3983. We have about 1 to 1.5 SWR. And that's into a dipole. I'm going to let it warm up a little bit here. Okay, so that was it's with 25 watts. I'll put it on CW where I can take the power up. I'm only driving this with about 50 watts, so let's see. CW, there's 50 watts. All right, so there's 50 watts at CW, and if you watch that, you'll see it's about 500 watts. And we'll take a look at the plate voltage too. I have it on plate. Yeah, no need for there, but plate right there. And it should just stay within the white. And of course the grid, that's the plate current rather, and the grid current should be also in that white range somewhere. One, two, three. All right, there we go. So we're going to power up the Heathkit SB200 on 10 meters, 75 watts. You can see right there. We'll see what we get out. I have this set at the plate, so we'll see if we can keep an eye on both of those. The plate and then the bird, of course, it has a 1,000 watt slug, and I have my power here so I can key the radio but not key the amp. So we'll see. We should see about 75 watts out, I guess. So look at the bird there. Yeah, that was probably a little less than 75. But, alright, so anyhow, we'll go on now. I'm going to put my switch on now. And we'll see what we get. Oh, here we go, ready. Nearly 600 watts. That's driving it with 75 on 10 meters. I don't think you can complain about that. So we'll call this a success on this, and a couple of things. I haven't decided what I'm going to do about that band switch behind there. It needs repaired. I didn't run into any parts yet for that. Hamfest season's coming up again, so we'll see what I can find, or maybe I can find an aftermarket switch that I can pilfer and use. But it's got redundant tabs on it, both the front and the back of the switch to make the contact, and it's for 80 meters. So 80 meters is running, it seems to work fine, but I definitely do want to get that fixed. The main problem was that I used this thing right after I had a problem with the gap antenna and didn't know it. I should have checked it with the dummy load before tearing it all apart, but I wanted to tear it apart anyhow because I wanted to change all those capacitors in the back and get a look at the tuned circuit. So maybe deep down I was hoping that it wouldn't work, so I could have a reason to tear it apart. Another thing I want to add, when I was testing this on the TS940, I didn't have this top plate on. I was doing it without that top plate on that screws on there. And on 10 meters, this thing would start to self-oscillate and basically key itself, and you couldn't unkey it without shutting everything off. and it did it consistently. And I was thinking to myself, why is it doing it all this sudden? Never did it before. And I put the top plate back on, so the RF must have been getting in there. That wasn't this time when I worked on it. That was when I originally got it. So I just figured I'd throw that out here. So all in all, we replaced some capacitors, a couple of resistors, cleaned up some wiring, and we're still running the tubes that came with it, which is an unmatched pair of tubes there, and I think you've seen them a couple of times in the videos. One of the other things is I have the cord that comes out, the power cord. Of course, it's not the original. It's after somebody installed it afterward, but it's about 12 foot long. But it looks to be it's at least number 14. So I don't know if that should really be that long. I couldn't find any specs that said what the original cord length was, and I imagine as long as it's thick enough that you're not losing any massive voltage drop, I still want to be able to look at the high voltage section. I'm showing about 2300. I know that they said it should be about 2400, but I think that meter itself also has seen better days. So I could always check that as well. But it's working fine right now. I've had good signal reports. I used it. I did want to add one thing. I was using it on 80 meters to talk to a friend of mine from the other side of the state, and I had this on and probably putting about 400 or 500 watts on. I was like powering this with about 50 watts, and it was fine. So I turned it off, and I still had he said it was still had a really strong signal. And I ended up knocking it down to just using the radio barefoot and knocking the power down to 30 watts. And we were able to carry on a very, very good QSO. So power isn't always the key. In fact, I think if I had the ability, I'd rather have a nice beam antenna. But anyhow, that's it. So that just about wraps up. I'm going to put this thing back together, put the outer case back on it, and I'm happy with the way it's working. And just a note to yourself, don't jump the gun and try to do anything without checking on a dummy load. Thanks for watching.